motion and measurement of distance.
Introduction. Imagine that you are back to school after a summer vacation. You are now in a higher class and you are not wearing the uniform you wore last year. Who made the new uniform? And have you wondered how much you have grown compared to the previous year? Probably your tailor took your body measurements to make the new uniform. What is measurement? Measurement is the calculation of size or extent or assessment of capacity. Measurement in ancient times. The principal unit of measurement in ancient Egypt was the royal cubit, a length we know to have been 52.4 centimeters, approximating the length of a man's forearm. Even today, we see flower sellers using their forearm to measure flower garlands. It was the Greeks who developed the foot as their fundamental unit of length. It was evident that everyone's body was of different sizes. This caused confusion in measurement. The French created a standard unit of measurement called the metric system in 1790. This is today's international system of unit for measurement. Unit of measurement. Your friend and you are sharing a desk in your classroom, and sometimes you have the feeling that your friend is using the larger part of the desk. How do you ensure that there is equal sharing of the desk between you and your friend? You might have played gilli and danda. Let's make use of the danda alone to divide the desk into equal parts. We measure the total length and find it to be made of 4 gillis. We can mark the bench equally by placing 2 dandas, and that gives the center point. Here, 4 dandas is a measurement that consists of 2 parts, a number and a unit. 4 dandas means 4 times the danda was repeated. That is, 4 is the number and danda is the unit. Hence, measurement is the comparison of the unknown quantity with standard quantity of the same kind. Standard units of measurements. In the previous example, we used the danda as a unit of measurement, but this measurement made by a person will not be a standard unit because the measurements made by different people will vary according to his or her age and physique. Thus, we need a universal or a standard unit. For the sake of uniformity in measurements, scientists all over the world have accepted a set of standard units of measurement. A standard unit is a standard or fixed measure of a physical quantity. The system of units now used is known as the International System of Units, SI units. Multiples and submultiples of units. A closer look at the meter scale reveals that each meter, m, is divided into 100 equal divisions called centimeter, cm, and each centimeter has 10 equal divisions called millimeter, mm. Suppose you want to express the distance from Chennai to Delhi, you cannot express the distance in meters. So, we use a bigger unit, that is, kilometer, km. We say 1 kilometer is equal to 1000 meters. Similarly, small measurements such as measuring the thickness of a coin or the width of a human hair requires a smaller unit. Thus, multiples of standard units are used for large measurements and submultiples for small measurements as shown in the table. Physical quantities. Length, mass, weight, time, speed, and temperature are some of the measurements used in day-to-day life. These are the quantities that can be measured and are called physical quantities. Physical quantities are broadly classified as fundamental quantities and derived quantities. Fundamental quantities are those quantities that cannot be expressed in terms of any other quantity and their units are fundamental units. Derived quantities are those quantities that depend on fundamental quantities and are expressed in terms of one or more fundamental quantities. Their units are derived units. The above table shows the derived quantities and their units. Measuring length. Measuring the length of your geometry box. The measuring tape, meter scale, and the scale are the most commonly used instruments. Let us use a graduated scale divided in millimeters and centimeters for our task. First step will be to choose a suitable unit of measurement. It is always advisable to make 3 measurements and calculate the average. Place the scale along the line and note the reading from one end of the box to the other end. Note the reading at the point exactly above the start and end of the box to avoid parallax error, which we shall see in the next section. We see PQ, that is, the length of the box is 6 centimeters. A measurement without unit makes no sense. Always write the unit after the number. Types of measuring errors. Zero error. This error occurs when the normal zero position of a measuring device is incorrect. For example, the meter scale might be worn out as shown in the visual. Parallax error. Parallax is the change in apparent position when an object is viewed from 2 separate points. For example, if you hold up 2 fingers in line with your nose and move your head from side to side while viewing them, you will notice an exchange in the relative position of the fingers as you change your point of view. This is parallax. Precautions that can be taken while measuring length. Keep the scale exactly along the length to be measured as shown in the visual. Place one end of the line segment on the 1 centimeter mark instead of the 0 mark if the scale is worn out near the 0 point. The eye should be placed directly above the reading of the scale, as in position B as shown in the visual. Measuring length of a curved line. The distance between any points along a straight line or a curved line is called the length. A thread or a divider can be used to measure the length of a curved line. Using a divider. Take a divider, open out its ends so that the distance between the ends is 1 centimeter using a scale. Now, using the divider, divide the curved line into equal parts measuring 1 centimeter each. Count the number of equal parts. The remaining portion may be measured by adjusting the distance between the 2 limbs. We arrive at the following conclusion. The length of the curved line is distance between the ends of the divider, 1 centimeter, into number of sections plus remaining length. The metric system uses prefixes to indicate the size of the units of measurement. Each prefix varies from the next by a factor of 10. It is either 10 times as large or 1/10 the size. Units of length and their conversions. When measuring length in the customary system, the common units used are inches, feet, yards, and miles. Units of length measure height, width, length, depth, and distance. The SI unit of length is meter, m. Measurement of area. Regular shapes. Measurement of area plays a vital role in our day-to-day life. For instance, to paint a room, it is essential to determine the area of the room before deciding to buy the paint. Area is the space within a particular shape and is measured in square units. The formula to calculate area is length of the object into width of the object. The SI unit of area is square meters, m squared. Suppose this room has a length of 5 meters and breadth 4 meters. We calculate the area by multiplying the length and width, that is, 5 meters into 4 meters is equal to 20 square meters. The area of regular shapes and other metric units of area are shown in the table. Measurement of area. Irregular shapes. We are now familiar with methods for finding the area of regular shapes, such as rectangles and squares. But is it possible to determine the area of irregularly shaped objects? How would you determine such an area without a formula? Let's explore. Place your hand on a centimeter grid paper and trace the outline. What unit must you use to determine the area of your handprint? The unit for measurement must be the interior of the closed shape and when repeated must cover the object of interest with no holes or gaps. Within the outline of the hand, count the number of full centimeter squares and the squares that are half or more than half. The sum of the two gives the approximate area. Measurement of volume. Volume of regular objects. Observe the different objects you see in your room. All the objects you see around has a depth or height in addition to the length and breadth. For example, your pencil box has 3 dimensions. Solid objects are enclosed by surfaces and occupy a definite amount of space. The volume of an object is the amount of space it takes up. The volume of a regular shaped solid can be found by multiplying the length, width and the height. The SI unit of volume is cubic meters, m cubed. The table shown here gives the formula to calculate the volume of regular objects. Volume of irregular objects. Suppose you are given 2 rocks of different sizes and asked to find their volumes. We cannot apply formulas that we used for the calculation of volume of regular objects. Let's use the technique called displacement. Take a graduated beaker or a cylinder marked in millimeters that is large enough to hold the rock. Fill the container and record the water level. Now slowly drop the first rock so that it is completely immersed in the water. Record the present water level and subtract the value from the original value. This difference gives the volume or the amount of space taken up by the rock. Rest and motion. A body is said to be at rest or in a state of rest when it does not change its position with respect to its surrounding objects. In other words, if the position of a body does not change with respect to any fixed point in its surroundings, it is at rest or in a state of rest. The state of motion depends on the position of the observer. Any object can be considered at rest or in motion relative to some fixed reference point. The states of rest and motion are relative. Rest and motion. Imagine that you are traveling in a moving train. There are many other passengers in your compartment. Is there any change in your position with respect to another passenger sitting by your side, even though you are moving with the train? Look at the nearby trees, lampposts, houses, people and animals outside. It looks as if the trees, houses and lampposts are passing by you at a great speed. But houses and trees do not move. It is actually you who is moving with the moving train. Types of motion. Everything in the physical world is in motion, from the elementary particles within atoms to the largest galaxies of stars. These motions can be translatory, rotational, or vibrational motion, as shown in the following animation. Translatory motion. Translatory motion is that in which all the particles of a body move through the same distance in the same time. When a body moves along a straight line, it is called rectilinear motion. When a body moves along a curved line, it is called curvilinear motion. Rotatory motion. Rotatory motion is that in which a body moves about a fixed axis without changing its position. Examples are windmill, fan, spinning wheel, etc. Oscillatory motion. Oscillatory motion is that in which a body moves to and fro about its mean position. The motion of a swing and the pendulum of a clock show oscillatory motion. The leaves and branches of the plant also show to and fro movement under the influence of the wind. Oscillatory motion. Oscillatory motion is that in which a body moves to and periodic motion. Periodic motion is that which repeats itself after regular intervals of time. The motion of the earth around the sun, the motion of a clock pendulum, heartbeat, pulse movement are a few examples of periodic motion. Non-periodic motion. In case of a non-periodic motion, the motion does not repeat itself after regular intervals of time. Examples of non-periodic motion are blinking of eyes, occurrence of earthquakes, playing a football on the ground, moving a car on the road, and occurrence of a landslide. Repetitive motion. Movement of lips while speaking, flickering of eyelids, the fingers of a person playing a guitar, violin or harmonium are some examples of repetitive motion. All periodic motions are repetition, but all repetitive motions are not periodic.
A car travels at a speed of 30 kilometers per hour for 30 minutes and then at a speed of 45 kilometers per hour. What is the total distance travelled by the car in 2 hours? On a 120 kilometer track, a train travels the first 30 kilometers at a uniform speed of 45 kilometers per hour. How fast must the train travel the next 90 kilometers so to average 60 kilometers per hour for the entire trip? The motion exhibited by the ball rolling down at an inclined plane is A. Rotational and circular, B. Linear and rotational, C. Rotational and periodic, D. Uniform motion. Which of the following doesn't undergo periodic motion? A. Rotation of Earth, B. Motion of second hand of a clock, C. A spinning top, D. Heartbeat of a resting normal person. Which of the following statements is not valid for both rotational and circular motion? A. Rotation about an axis passing through the body. B. Body moves and changes position with respect to time. C. Body stays in the same place with respect to time. D. To and fro motion of a body about its position of rest. How will you measure the circumference of a given cylinder? How will you measure the volume of a stone by using an overflow can?